Hi, welcome to today's Science Short. I'm Tyler, a field engineer here at One Energy, and today we're diving into oscillation. Oscillation is a repeated motion over a period of time about a central point. This type of motion occurs in various natural phenomena. Imagine the regular back and forth motion of a swing at the park, or the pendulum of a grandfather clock swinging from side to side. Let's focus on the example of pendulums. Pendulums have two distinct turning points. As it reaches the highest point swinging to one side, it falls and swings to the other side. This pattern of motion repeats on the other side. This gives us two turning points, here and here. Physically, the motion of the pendulum can be understood by analyzing its energy. There are two types of energy involved in the pendulum's motion: kinetic energy and potential energy. Since energy is never destroyed and always conserved, the total mechanical energy of a simple system will be the same during the entire oscillation. Now back to our pendulum. Our turning points describe the moments at which all of the kinetic energy transfers into potential energy. This is because the turning point is the highest height it reaches before pausing. Thus, at the brief pause before it swings back in the other direction, the potential energy is at its maximum. Let's visualize this by looking at an energy bar graph side by side with the motion of the pendulum. We'll start by releasing it from one side. And before we let go, notice how the total energy is equal to the potential energy. As soon as we let go, the kinetic energy increases as it swings to the other side. At the lowest point, the kinetic energy is at its maximum. Notice that the total energy is now equal to the kinetic energy. This occurs at the central point where the pendulum has the greatest velocity. As the pendulum swings up to the other turning point, we see the kinetic energy start to drop and the potential energy rise. We see on this side of the swing that the potential energy has now reached a maximum again. This is our oscillation. We can see that as the pendulum swings from side to side, the total energy oscillates between kinetic and potential energy. In summary, oscillations are a fundamental aspect of nature, characterized by regular repeated movements about a central point. Understanding them mathematically allows us to make predictions and design machines like wind turbines, which efficiently convert the natural oscillatory motion of the wind into useful energy. That's it for today's Science Short. Thanks for watching, and remember, challenge everything.